So the first cell, let me designate it as a text cell, and I write here my problem. So in this cell, I would like to plot the data of radioactive decay, right? And write the equation. Okay. Begin equation, and I write here n of p is equal to n naught e raised to the power lambda times t. And that's it. This is yes. Of course, there must be a negative sign and equation. So this will appear. Okay, that's correct. Now we require the libraries. So I write import numpy as np, right? So vector can be easily defined with numpy, and a plot library matplotlib dot pyplot as plt, right? Let's I define the n naught value. Say, as I said, I will take 100 value. We'll call 1000. Okay, lambda value, say it is equal to 0.03. Now the vector, I require 1000 values. So I define n values, or you can say this is parent nuclide, and p, it is numpy array. And for 100 steps, so I set this array numpy zeros 101 and in one column, right? 101 rows and one column. These are all values set to 0, right? So initially all values will be created as 0. So for time vector, I say numpy range. So these values are up to 0 to 100, right? So a range by default it runs from 0. So these are going to be two vectors which are created, right? So we can see these vectors and everything. Now the first value np first entry. So the index begins from 0, very similar to C language. So this is equal to n naught. So this is the value nuclides at the beginning. Now I start a loop for I in range. First value has been started. First value has already been given, so I will start it from 1 and I will go up to 100 steps. So therefore 101. This is going to be one value less than that. And then this is the colon notation. So np of I will be equal to n naught times exp. Exp value will come from the numpy function. So it is minus lambda times the t value, and I will get the ti value, right? And that's it. And there is no need to write a parenthesis like this. Time. Yes, the vector was time. It's not t, it's time. So there is no need to write a parenthesis like this in Python. When you get out of the indent, it means for loop is ended, right? Now I plot, I would say PLT plot time and the number of nuclides, and I plot it with red circle, and I can say PLT show. So let's see whether there is some error or not. See the output of this. So it's busy. We are using the Google server. So from Pyas, from Pakistan, okay, there is some error. 0.03 lambda cannot interpret 1 as data type. Okay, 101. Okay, numpy zeros. With comma, it should be the data type with data type float, right? I think now it is correct. Okay, that's fine. That's great. So we have got the radioactivity plot. Now I'm going to make a slight change. Within these commands, I can say PLTX label. So on x-axis we have time, right, in units, and on y-axis I can say it's y label. It is the nuclides, and if I really want to see whether it's an exponential relationship, let's change the y scale. I say y scale, set y scale to logarithmic, right? And another thing, I say show the grid line. So I say grid on, right? So a few steps. After that, now if I run the same set of commands, so see the straight line, and the scale has been converted to logarithmic, and we have got the straight line, which means the exponential relationship has been drawn. Similarly, you can have both scales logarithmic. So today I have added the facility of changing the scale, right? So you can plot and change the scale so that you can see the behavior, right?